This assessment asks us to predict the product of the reaction of an acid chloride with 2 equivalents of butyl lithium. Let me redraw the molecule so that we can show mechanistically how this is going to happen. First of all, we recognize that butyl lithium, we can think of it as a negative charge on carbon with a positive charge on the lithium. And so we can think of that as ionic. Even if we drew it as covalent, we can get ourselves to the same place by recognizing that that butyl lithium is a really, really strong nucleophile. And the acid chloride is a highly reactive electrophile. And so in the first step, the nucleophile is going to add. If we use the ionic version of butyl lithium, it looks like this coming from the lone pair. If we were to use the one where it looks covalent, we could simply show it like that. Either way, we get to the same place. And that place we get to is the tetrahedral intermediate. So when the nucleophile adds, we will have, at least temporarily, this tetrahedral intermediate, where we formed the new carbon-carbon bond. We have chloride as a good leaving group, and we have the alkoxide. At this point, the fact that I've called it a tetrahedral intermediate tells you what's probably going to happen next. These electrons are going to collapse back down, reform the carbon-oxygen pi bond, and eliminate the chloride. So we have nucleophilic addition and then elimination to kick out the chloride. At this point, we've made our new ketone. We've made a ketone. Now, we have 2 equivalents of the butyl lithium, and we know that the organolithium can react with the ketone itself, so we can draw it this way. The nucleophile, the strong nucleophile, adds its pair of electrons to the carbon, pushing the electrons onto oxygen. Now, we don't call this a tetrahedral intermediate because there's nothing that can be eliminated, but we have formed the second of our carbon-carbon bonds. And so we end up here. And this molecule, with no way to decompose, it sits around and waits for us to add our acid for the acid quench step. And so we can show the product of the acid quench step by protonating this alkoxide and giving us as our final product the tertiary alcohol. This is the product of the reaction on screen.